In this problem, again, we have a car headed north and a car headed south. They collide and they stick together. And the question is, what is the impulse for the car headed south? Remember, impulse is change in momentum. So let's go through what we did with the prior problem and let's calculate the total momentum. Now, again, north is our positive direction. And so M1, our total momentum before the collision, V1, minus M2 V2, because MV2 is headed south, right, equals, now after the collision, M1 plus M2 onto some velocity we don't know yet, V prime, and it's M1 plus M2 because they're stuck together now, and they're moving it as one object. I'll just go ahead and solve for V prime. Let's get V prime is M1 V1 minus M2 V2 divided by M1 plus M2. So that's V prime. The question though is, what is the change in momentum for the car headed south? Well, the car headed south has an initial momentum of minus, remember the minus sign is there because it's headed south, right? And then it has a final momentum that's given by M2 V prime. So even though car 2 is now stuck to car 1, you can still break that momentum out into two pieces, M1 V prime plus M2 V prime. So this is the momentum of car 2 after the collision. And what we're after is the impulse, which is going to be equal to the change in momentum, which is going to be P2 prime minus P2, which in this case is M2V, can't type a 2, M2 V prime minus a minus M2 V2, which is M2 V prime plus M2 V2. Right? M2 V prime plus M2 V2 is the impulse. J equals, I'm just going to get lazy and do a copy and paste. So let's do some calculations. M1 V1, M2 V2, V prime. That's our first step. So 1483, 21 meters per second, 1123 kilos for M2, 10 meters per second. Again, we have a numerator with more than one term in it, so I need parentheses. M1 times V1 minus M2 times V2. And we also have a denominator with more than one term in it, so I need parentheses, M1 plus M2. So now we have V prime, and we need to calculate the impulse J. So J is going to be M2 times V prime plus M2 times V2. And so J is 19,811 kilograms meters per second. 19,811 kilograms meters per second. And that's it for this problem.